If you're participating, let me do that again.
Hello, everybody. Good morning and welcome to OpenCV Weekly. I'm Dr. Satya Mallick and I'm the CEO of OpenCV. Today, we have two guests from Intel, Abhijeet Mazumdar and Smitha Girish will be showing and telling us all about the incredibly useful Intel Edge Software Hub, a one-stop resource for streaming and optimizing edge AI solutions. It promises to be a very educational and valuable presentation. But first, with me, as always, is Phil Nelson, the Director of Content and Creative at OpenCV. Phil produces the show, and if anything goes wrong, it's his fault.
Thank you, Satya. And that's right. It's me once again, the co-host with the co-most, the second banana who is second to none, your plus one and only Phil Nelson, here to remind you of a few things we do every single episode here on OpenCV Weekly, the first of which is a giveaway to you in the audience. Stay tuned. Later in the show, we will be asking a trivia question. If you answer it correctly, you'll be able to win the OpenCV course of your choosing. We are also taking Q&A from you in the audience. So if you're watching us on Zoom, use the little Q&A button at the bottom of your screen. Or if you're watching us elsewhere, YouTube, Twitch, Twitter, Facebook, LinkedIn, ask your question in the chat or comment section of that service, and we'll do our best to flow those into the conversation. We'll also try to save some time at the end of the webinar to answer questions we didn't get to during the episode. No promises there if we go along. But before we get started, we've got a couple of reminders and announcements here about OpenCV business-wise. OpenCV AI Competition 2022 is still going strong, but we're coming up on the submission deadline of December 18th. If you're participating, please let us know by posting on social media with the OAK22 hashtag. Show people what you're working on. We're sure it's exciting and we want to see it and hear about it. We'll be following up with an email to all participants on both tracks about how to submit their final projects later in December. Good luck, everybody out there, and thanks for your hard work. Also, OpenCV AI Scavenger Hunt is a wrap. Thanks so much to everyone who participated in this unique competition and for your patience that we've had a couple of weeks of delays, which stopped us from announcing the winners, but the grand prize winner will be announced in the newsletter next Tuesday. The best way to find out first will be subscribing at opencv.org/subscribe. We'll also have a special segment about the competition on the episode of OpenCV Weekly next week. Back to you, Satya.
That's great. Thank you so much, Phil, and welcome both our guests. Let's start by a short introduction. If you guys can introduce yourselves, and then the show is yours. We're very eager to go with the presentation.
Indeed.
Thank you, Satya and Phil. So first of all, I'm very honored to speak on this weekly webinar. So getting promoted from the viewer side to the presenter side feels really awesome.
Nice.
So I'm Abhijeet. So I basically have experience in industrial side when I was working with GE for 4 years. And then I'm with Intel for the last 2 years, where I've been working in the developer solutions enabling group, which basically tries to make developers into super developers by their awesome software stack.
That's great. Smitha?
Hello, everyone. I'm Smitha, Technical Product Manager from Edge Software Hub. I've been in the industry from last 17 years. Looking forward to this exciting show.
All right, so
Over
the
to
show
you,
is all yours. You guys can start the presentation. Very eager to know about the Software Hub.
So like I was mentioning earlier, we are from the Developer Solutions Group, and we try to build solutions which basically helps developer all around the world. So what if I told you that you can actually create an end-to-end AI application which runs well on any available hardware in just under 10 minutes? You'll be shocked, right? But by the end of this video, every one of you who is watching can definitely do that. So I'll quickly start the presentation, which involves less of technical depth and more of demo and live actually trying out the solutions, so that everyone here can actually grasp them and try it out themselves whenever they try to develop any solutions.
Yes, stay tuned for a brave live demo, our favorite thing on the show.
So fingers crossed. So um,
You have to read
any
that very fast. Just
yes,
kidding.
this one.
The
So
legal disclaimer, right?
Here, let me see if I can pull this off. Information in
yes.
this document is provided in connection with Intel products. No license, successor, implied, estoppel, or otherwise, or intellectual property rights is granted by this document, except as provided in Intel's terms, conditions of sale for such products. Intel assumes no liability whatsoever, and Intel's claims any express or implied warranty relating to sale or use of Intel products, including liability or warranties relating to fitness or for a particular purpose, merchantability, infringement, any patent, copyright, or other intellectual property right. Intel technology features and benefits depend on system configuration, may require enabled hardware, software, service activation. Performance varies depending on system configuration. No computer system can be absolutely secure. Check for your system manufacturer, retailer, or learn more at intel.com. This document contains information on products, services, or processes in development. All information provided here is subject to change without notice. Contact your Intel representative to obtain the latest forecast, schedule, specifications, and roadmaps. Intel, copyright Intel Corporation. Intel, the Intel logo, and other Intel marks, trademarks of Intel Corporation or its subsidiaries. Other names and brands may be claimed as property of others. All right, there you go.
Awesome.
So I guess you have many hidden talents.
Yeah, yes.
So any application that involves the use of AI uses pretty intensive memory and lot of computational requirements. So as per the data from Gartner, it is estimated that more than 75% of the enterprise generated data will be created and processed outside the traditional data center. So what is meant by that is that a lot of data points will be generated using edge devices. So basically edge devices are the devices which are kept on premises. So for example, I'll just go through couple of examples to help you understand better. So the first example I would like to give is, imagine a potato chip manufacturing company. So their requirement is to detect and remove all of the faulty potato chips which do not meet their quality standards. So how it is done is that there is a air blower as well as a camera which actually surveys the complete production belt. So whenever the camera detects any of the chip is faulty, the air blower must remove the chip from the production line. So what this means is the system must have a very high computation power to process the video, as well as a very low latency to help actuate the wind blower to remove the chip from the production line. So this is an example of how an application is hosted on premises, and it helps cut costs and save face for a very large organization. Similarly, if for an organization like Walmart, they have multiple hundreds of supermarket chains across the country. So if they want to run a behavioral analytics where they try to deduce by the help of age groups which customer prefers what product. So they gather a lot of information through either sales data or through videos, is that where actually a 25-year-old man looks towards in the center. So it helps them stock their products well and helps them uh, also optimize their shelves so that they gather more sales. So these kind of applications require huge amount of data being processed and analyzed on uh, on either on premises or on cloud. So this is a collaboration between the edge device as well as a cloud device.
So
Now,
the
why I
potato,
am yeah,
the potato chip example that you gave, that's a real example, right? So
yes.
I have never seen this, but is it like a conveyor belt on which each potato chip goes through a conveyor belt and it's inspected before it's packed?
Actually, there are more than like thousands of potato chips which actually flow in the container belt, and there
Okay,
would be this 6 to 7 guns of air which would be moving, and they would shoot the potato chips out of the line, and it's very interesting to watch. So
nice.
if
Yeah,
you
they
get
do.
a
It's like
chance, yeah,
just
yes,
little bursts of air. Yeah.
yeah. So these applications are just an example, a very minor example of the whole plethora of applications which exist in today's world. And these applications basically involve a huge amount of video analytics and audio analytics, text processing, time series data analysis, and all of these are done on edge. So that is the reason why involving in edge optimization and creating solutions which can be reconfigured, reused, and reduced time to market is very critical. Now, basically, what are the challenges that developers face on developing edge computing applications. So basically, the first and foremost is the limitation. So there might be a hardware limitation. There might be a positional constraint where the device must be kept this close to the device, to the actual system. And there might be space constraint, physical space constraint. And also there might be even a budget constraint that we need to put 100 devices, but our cost is only, we can go until, let's say, $100,000. So there are a lot of limitations in terms of that. Also, there is a huge requirement of faster time to market, because if the solution is required today, we cannot spend six months to 12 months developing the solution and then get it ready, because the requirement is for today. So we need to develop it in within at best couple of weeks. And the last one is, how do we make sure that all of the applications that we develop work in a similar way across all of the devices that we have shared. So that is a constraint of homogeneous performance across the devices. Now, we at Intel focus to remove these challenges that the developers face while creating an edge application. So basically, uh, we have all of these softwares already available, deployment ready reusable packages, as well as few of the reference solutions across the verticals that any developer can learn from and use to face all those challenges that I mentioned in the last slide. So the ready to use solutions will reduce the time to market, because we just take from the reusable microservice and reusable libraries, and we just write a very low code or no code configuration changes on top of that, which makes the time to market very less. We also have various benchmarking applications which actually can be deployed on any Intel hardware to see your application performing in them, and helps you choose which hardware is actually optimal for your application. And we also reduce development cost, because every application that is available on Edge Software Hub is hardware optimized and performance optimized. So you do not need to worry about the back-end performance, because everything is optimized based on the hardware you choose, and you can just run it with very minor changes in code, which I'll be showing you in the slides further and in the demo as well. So here's a very short introduction on the Edge Software Hub.
Blank screen here for me.
Yeah.
So I
Here we go.
think
Yeah,
I
now
missed
we
the
can.
audio.
Yeah,
Let me share.
Everything
it
was
began.
fine.
Yeah, it began
Yeah.
working. It was just kind of laggy for some reason.
Yes. So I'll just.
Sounds like a Telecaster to me.
Cool.
Sweet.
So I hope that gave some little bit insight on what Edge Software Hub is. So now I'll be speaking a little bit about each of the components that are available on Edge Software Hub. and also showing it to you on the website, how to navigate through it and select your software solution or reference solution to try it and benchmark across multiple hardwares. So the major offerings for the Edge Software Hub are Edge software packages, reference implementation, deployment configurator, and recommended hardware, where you would actually try your solutions on multiple Intel hardware and view the benchmarking results, which will help you actually to choose the hardware. So coming to the Edge software packages, uh, sorry, the reference implementation. So what reference implementation is, it's basically an end-to-end solution which might be in a microservice format or which might have reusable components between them as well. So across the verticals, we have figured out a few important solutions which are widely required in all of the verticals. For example, it could be in retail space, it could be in industrial space, it could be in healthcare, or it could be in the automotive space as well. So on those space, what are the most widely used or widely required solutions? So taking uh, the motivation from those requirements, there are multiple sample solutions or reference solutions which are already available on ESH. So you can just configure and download any of the solutions to actually run that on your local system or at any Intel device of your choosing, and actually see how it is implemented, so that if your required solution is near or closer to the already existing reference implementation, you wouldn't have to spend much time creating a solution from scratch. You would be using the open source code directly and changing some minor configuration or writing a very minor post processing script on top of it, and you can get the solution ready. And apart from that, you can also know how your solution will perform on any device before even trying that or trying to go to the deployment aspect. So the Edge software packages, basically these packages are a little bit more wide horizontally. What I mean by that is they contain a lot of reusable components which can be configured individually to create solutions among each vertical. So these software packages, basically they do not have a solution directly, but you can use these packages to create solutions. For example, the edge insights for autonomous mobile robots. So you can use this stack to create multiple robotics applications using the stacks, and the stacks will give you end-to-end integration for all the data transfer, database management, as well as integration using the ROS2, which is widely used for autonomous mobile robots. And all of the required ready to deploy solutions are present. You just need to insert your application code into the container, as well as the post processing script. For example, how much distance to move or which object to grab, something like that. So you can just use these software packages and create a complex or end-to-end solution on your own. So now I'll be spending couple of minutes on actually showing you how the Edge Software Hub looks and how to navigate through it.
Mhm.
So let's just search on any web page, Intel ESH. So you'll go to the landing page, which is Intel Edge Software Hub. So once you go inside Intel Edge Software Hub,
We sent too many people. We broke it.
so we can actually see that there are three verticals basically. So the software packages, which I was speaking about earlier, are present here. So for any software package, you can actually visit the documentation or click on learn more to try it out on your system. You can configure it and download, or you can just go through the documentation to understand the stack, what it contains, and how it has all the required optimization code for any hardware or any pipeline that you have in mind.
Is there a difference
Similarly,
between what you call edge insights and edge controls, or it's just a name?
yeah, it's just the name because this is basically a package for designing control systems on industrial machines, specifically to it has like a lot of industrial standards integrated inside it, and the connection security, and so those kind of things are involved here. So it's basically controls for the complete industrial space. And
Got it.
here you basically develop the applications. Like for example, the if I take an example of rotor bearing defect detection, so those kind of applications you can develop using the edge insights for industrial, which is on the application side, and this is for on the control side, like whatever is required to control the industry.
Got it.
So if we go to the hardwares and device section, so here you can view all the available hardware that Intel has. For example, i3, i5, Xeon processors, i7, 11 generation, 10 generation. So you can view all the hardwares here and select the ones which you want to test your application on. And the reference implementation that I was speaking about comes under the use cases part, where you can filter all the applications using the verticals they belong to. And you can actually click any of them and just try to see what the application is and just run it in your system and look at the performance. So you can see a very basic explanation of the application here, what it does, and the all the steps required for you to run the application on your system. Later, I'll also be showing how to run any application available here on the DevCloud platform that Meghna mentioned in the earlier session.
Yeah.
How to run any application on that by selecting your device of choosing. So going back to the presentation. So
And it
for
also comes
the,
with
yeah,
a system, it also tells us about the system requirements for what kind of
yes,
system is required to run this kind of application, which is pretty handy, right? Otherwise, you spend a lot of time figuring out how much is needed.
exactly. And that is the reason we also provided the DevCloud extension,
Yeah.
where, for example, if you do not have this availability handy in your local system, it might be full, or you might not have an Ubuntu device. So you can choose the device and directly run it on your web page itself without even bothering to download it.
Okay. Nice.
So talking specifically about video analytics, because the reference implementation that I'm about to show you now in the demo belongs to a video analytic application. So speaking a little bit on top of that, so we have basically two reusable pipelines which are already available for any developer to use. The first one is the DL Streamer pipeline server. So DL Streamer basically is a pipeline created on top of the GS Streamer, which basically optimizes the inference using Intel OpenVINO, which is again using OpenCV and lot of backend libraries for optimizing your model as well as the inference performance on Intel devices. So the DL Streamer basically uses those libraries and creates a very user-friendly reusable pipeline, which basically can run just by uh, configuring what model to use, what task to perform. For example, is it an object detection? Is it a person detection? Is it a vehicle detection? So you can mention that, what to detect, and you can have an RTSP stream directly linked in the configuration file, which will help you process any incoming video stream directly. So you do not need actually to write any application for that. You just need to connect the dots. So
Yeah.
the dots are clearly explained in all of the documentation. And coming to the Edge Video Analytics microservice, that is basically a another reusable component which is created on top of the DL streamer. So that is basically a independent microservice which can be used directly. So for any developer who wants to just try an application which is already hardware and software optimized on Intel device, can just take this Edge Video Analytic microservice, or EVAM as we called it, we can take this and directly deploy optimized media analytics pipelines. So this actually is built on top of the existing DL streamer pipeline, because the DL streamer still has a lot of configurations, and for a user to be well versed with that, it takes a little bit of amount of time. So it doesn't take as much as time to develop from scratch, but it requires a familiarity. So for
So
when someone, yes.
one question. I mean, I just want to make sure that we are all on the same page. Does it mean that, let's say, I this particular microservice, right, video analytics, I just want to do person counting, right? I want to do person counting of all the people who are coming into a store, right? Just count them, right?
Yep.
Does it mean that, okay, if I buy the Intel hardware mentioned here, right, I'll buy a physical computer and I'll connect, a camera to it, and I use this software out of the box, will it provide everything that is necessary for, let's say, person counting with a little bit of code, extra code, or how does it work?
Yes. So if you already have a camera
Yeah,
and a small device which is capable of running this particular microservice,
yeah,
then you would have everything required for you to count person, or even stream multiple videos inside and do a multi-camera application as well. So everything lies in the configuration file. So you just
got it.
need to mention that this application needs to detect person,
Yeah,
and then a small post-processing code which would actually enable you to count those person, because after detection what
yeah,
needs to be
whatever.
done is
Yeah,
on the user's end. Yeah.
right. Okay, but these services are running on the host device, right? It's not going to the cloud,
Yes.
nothing. It is basically the camera and the host, which
Yes.
where all the things are happening, right?
Yes. Yes.
Okay.
So we also have cloud integration applications as well. So
Yeah.
for example, if you have hundreds of edge devices which are connected to 100 cameras, and
Mm-hmm.
they're able to count the number of persons individually, so they can connect to a master or a host or a central application on cloud, which will keep track of all of those things and store it inside, let's say, your local database or any requirements you might have. So even that is possible using like a Kubernetes cluster.
Okay.
So speaking further about the architecture of EVAM, the Edge Video Analytics microservice. So as I mentioned, it is built on top of the DL streamer pipeline server. So the pipeline server is built on top of the optimized OpenVINO toolkit, and there are few pipeline definitions which are configurable based on the application that you're looking towards. And the the EVAM, what it does is it has a config manager which actually converses with the DL streamer pipeline using REST API, and it actually uses the Edge Insights for Industrial message bus library. So that message bus library is basically a single way of communication, two-way communication, which helps us connect this microservice to any other available microservice in the system. So DL streamer doesn't have that capability directly, because it just detects and it will uh, use the post processing script to do a certain action. But using this Edge Video Analytics microservice, we can use this additional capability known as the EII message bus library, which basically will help you connect this microservice to any further microservices or application directly. And this config manager is the only one that you need to interact with for configuring your application entirely. So there is just a need for you to mention what needs to be done and which model to use. And here you'll just need to mention which container to send your data. So for example, you might be using Grafana, you might be using InfluxDB for storage, for visualization, Kibana, Grafana, or any other UI application. You would be using this EII message bus library to interact with this container. So about a little bit about the application that we're going to see in the demo. So it would be a multi-camera social distancing violation detection. So during the COVID, it was required that there needs to be an application which actually detects any social distancing violation counts. So basically, if any two people are less than 6 meters away from each other, 6 feet away from each other, we would actually count that as a social distancing violation, and we would record that as part of a event trigger. And a multi-camera application will help us help all the developers seeing this video understand how a single microservice can uh, use multiple camera streams and detect them and process them, so that we can use EVAM as a single solution for any application which uses multiple cameras. So we'll be navigating through the Edge Software Hub and selecting this application, downloading this, and installing the application and running the application.
And you promised us that this will all be done in less than 10 minutes.
Yes.
All right.
No pressure.
So if, like I earlier showed, when you traverse to Edge Software Hub, you can actually select the use cases from Edge Software Hub and go to the exact use case, any use case which you want to try out. For this demo, we'll be trying out multi-camera detection of social distancing. So we click on that and it opens the page of the reference implementation. And there is a target system requirements like Satya pointed out. So you can check if that is what you have already. You can then configure and download it. So one thing which you get while you download is the product ID. So make sure that you copy the product ID and keep it somewhere handy, because while the application is getting installed in your local system, you would be asked for this product key. So you need to copy this and save it somewhere for the application to run. So there would be a zip file which is downloaded, and once you download that, you go back to the website and you can see the step-by-step definition of how to run this application. So I'll be putting the screen side by side so that we look at the steps and we see it happening on the terminal. So in the terminal, we just unzip the folder which was downloaded earlier, and we basically run the Edge software executable which is available, and this is same for all the applications which are available on Edge Software Hub. So there would be a single executable called Edge Software, and we just need to install it.
Okay.
And it automatically takes care of the installation. And like I mentioned, you will be asked the product key and you just need to paste it here, and then the installation starts. So I'll just go to the part where we finish the installation here. So it takes almost, it's 3:20 here. It takes almost 7 minutes to install the application.
Okay.
And we wait for the application to show all the status as success. Now, wow, one critical insight for all the developers who are trying out any application from Edge Software Hub, if you look at any of the containers and if it fails any of the services, then if it is usually the database or the UI service would fail, like the Grafana or the InfluxDB, which is used amongst most of the application. So if it fails, then you just need to look at your ports if they are free or not. So just by freeing all the default ports which they use, you can make this as success and you can start the application, because sometimes the ports get in the way. So it's just an insight for anyone who is trying out applications from Edge Software Hub.
Okay.
So we have finished installing the application. Now what we'll do is we already have a video with this application, but we are going to use two videos to show you the multi-camera streaming aspect of it. So we'll just download a sample video and we'll just paste it inside the resources folder inside the application itself. So all the steps are available on the website itself. So we take the sample video and we download it, where we see a lot of people walking. and we actually paste that video inside the resources folder. And then we download all the models required for the video analytic. So object detection and person detection, both the models we download, and we just run these two commands for downloading the models. So once they're downloaded, so you can look at this small example of a pipeline. So earlier I was mentioning that with very minor uh, configuration or pipeline definition, you can create multiple applications. So here is the example. So in the template, you can see that there is GVA detect model, and we mention which models are present in the, we downloaded this model earlier. So we mention which models are needed, and then we use the, this is basically the post processing script, which is used to actually count the people and show the results. Here, if you are running a classification problem, it would be mentioned as GVA classify, and same, the model definitions are needed here. So by changing this configuration pipeline, you can create multiple solutions using the same microservice. So that is the advantage that any developer gets when they use the DL streamer pipeline or the EVM microservice directly. So we now run the application, which is just restarting the containers. So it would actually take in, this is the actual configuration file, which contains all the configurations here. And we actually run the application, and it's a person detection application. And we view the application running. So we go to localhost 5000, which is basically the Flask server showing you the output video. I'll just pause for a while. So this is a video which was already present in the application in the resources folder. This is an additional video that we added from as a sample. So what the application does is it detects all the people inside the video, and it measures the relative distance between them. And if the distance is less than 6 feet, then it marks that event as social distancing violation, and it stores the timestamp and along with the channel that it is coming from. For example, if you had 10 videos here, the channel would be named from channel 0 to channel 9, and we would be having separate tabular output for each channel when the social distancing violation occurred, and the count basically.
For each camera, is there a configuration that, because the 6 feet is not it's not obvious from a single view how you are measuring 6 feet. So is there a sort of a calibration thing that is done, or?
Yes. So in this application, it is assumed that a person is 5 feet 6 inches tall.
Okay.
So assuming that, we are calculating the relative distance, so that like every person's height is average.
Okay.
So that was done as a part of the assumption in this application.
Okay, and then the assumption is that the camera is so far away from the floor that you can make that assumption.
Yes.
Yeah. Okay.
So the bounding box center to the next bounding box center would be calculated based on the bounding box height, so the person height. So we can see that the application is able to process both the videos, and I'll be showing you, we also have a Grafana dashboard integrated with this application, which will help us view the analytics and with the timestamps. So all of these steps are again mentioned in the documentation from the website itself, and you can see that based on channels, uh, what was the people count and how many social distancing violations happened during this exact time. And we can see the complete graph here. So it is stretched to 6 hours. That is the reason we see a very thin line here. But if we change that to, let's say, last 15 minutes or so, you can view the counts as a, so this is based on, you can change it later as well. Once you download this application, you can add further dashboards and play with it. And if you want a better analytics, a better view of analytics, you can definitely configure here. It will not affect the application. So you can also see individual channel based violation counts, as well as the number of people count live. So whenever the video would, so assuming that this was a video which was stored in the resources folder, but ideally this would be connected to a live camera. So once we configure that, the count would be shown in time, look, live. So similarly, as we installed the application, we also can uninstall the application directly using Edge software uninstall. So we stop all the containers, and then we just write Edge software uninstall. So basically it would uninstall all the packages which were installed and make your system ready, or like removing all the packages which were installed.
So what happens if I decide to, this looks great, but let's say I want to train my own model and replace, I want to use all the infrastructure that is provided in this package, but I just want to replace your model with my own custom model. I mean, it could still be doing person detection, but a better model. Let's say for my application, I have more data and I just want to retrain that person detector with a better person detector. Is that possible?
Yes, that can be done directly. So the step where I had shown the model downloading aspect, so
Yeah.
I'll just quickly point it out there. So it was somewhere, yeah. So post installation, we downloaded these models.
Yeah.
Which, so pre-installation basically. Yeah.
Okay, so we can just
Yeah. So you see this models folder here. So you
got
can
it.
place your own model here, and
Okay.
in the configuration, you just point your uh, the microservice towards this new model. So just you need to replace the name,
Yeah.
and it should consider that as the model and function directly.
Yeah.
And one insight on this is that since it uses OpenVINO as the main application for inference,
Yeah.
we would need to make sure that the models are in IR format, which
Yeah.
the OpenVINO can understand. So that
Yeah.
is the only conversion that you need to do.
Right. Yeah, and that
Even
that
that is
pipeline
done
is
by the
very
same.
robust.
Yes.
Most of the time, it's very easy to take a PyTorch or TensorFlow model and convert it to IR format.
Exactly, yeah. Because once you install this application, then there is also an OpenVINO uh, container with it. So even if you do not have OpenVINO available in your system, you can use that container and its services, like the model optimizer, basically, to convert your models directly using the microservice as well, if you do not have it installed earlier.
Okay.
So now, since we have a couple more minutes available, so I'll also show if, for example, any developer, if they do not have the available system requirements, for example, this list that we see here, how can one actually test an application and see it working on any of the available Intel offerings?
Mm-hmm.
So we take this similar application, social distancing for retail settings, and we try to run this on a list of available Intel hardware. So it would just take 4 to 5 minutes. So you open the application, social distancing for retail settings, and we see a link which is enabled here, launch on Intel Developer Cloud for the Edge. So basically this is the platform where we actually help the developer to choose any of the Intel devices and try to benchmark the application on it. So the link for DevCloud would open once we click that, and basically anyone who visits here needs to register first. So I'm already registered, so I get this page directly. But for any person who is trying out this for the first time, you would be asked for registration, and it's a pretty straightforward registration by email. And once your account is active, you will be seeing this page, and you can select, let's say, what is the target platform family. based on your budget and based on the experimentation that you want to do. You can just try it. For example, let me select an i5, which is fairly median amongst all of these platforms. And I can select whether it's an 8th generation or 11th generation. So let me take the latest one and I'll just click on launch. So what it does is it basically queues the application. So for example, I was trying this out earlier, 30 minutes back. So I'm trying it again. So if I try a new application, it would be queued directly here. And you would see a list of all the applications that you have tried and the target device. And it would soon deploy on the available device in our lab. And you would be able to see all of the analytics and metrics here.
Right.
So here, for example, if you are on this page, but you also need to download and run your application locally. You want to try it out on, let's say, one of the Intel offerings, and it might be a upgraded version of your current hardware. So you might have, let's say, i5, but you want to try it on Xeon. So you can actually download this application even from here. It would just open the same configure and download page. So you can try it out parallelly both on your own device versus a device available in the lab. So now we can see the status as running. And once we uh, click on output, so it's a Grafana dashboard for the application, which would open here. And we can actually go to the dashboards and view the performances. So this is again the same video, but replicated 4 times to help anyone show that even 4 videos can be tackled at a time, and you can see the benchmarking for 4 videos parallelly in the application. So you can view all the data points here, and you can also view all the streams which are getting like the localhost 5000 which I showed earlier. So these are the streams which are running parallelly, and you can see the FPS, what is the performance when 4 streams are processed parallelly. And additionally, yeah, so you can see the containers which are running and even their performance. So telemetry data is being calculated. So each container's CPU usage, RAM usage, the temperature of the CPU which is running in the lab, everything would be shown here. So you can compare that against your own device and understand if there is really a jump in performance once you upgrade your device, or whether it fits your constraint that you're looking towards. So you can view at the logs, and you can view at the terminal. You can connect to the containers and you can type in your own commands if you want to try them out. So everything is very user friendly, and I think you do not need to download anything in your system just to play with it.
Right. Yeah, and it's also, from a practical point of view, let's say you're a student, you want to show something as a demo, you can quickly create these things without worrying too much about how the whole system comes together. You worry only about the computer vision or the machine learning part of it. And the same thing applies to if you're working at a company and you're going to show a demo to your boss, then if one of the reference implementation fits, then you can look very, very impressive, even though you're doing the same amount of work of training a model, but you bring the model to this system, and everything looks really impressive.
Exactly. And the question which you asked earlier, how do I replace the model? You can also do that by going to the container here directly. And you can just, the application container would be here. You can click here, go to the terminal, and actually traverse to the path where the model is located. And you can download, run the like command to download your model, and then change the configuration file from here itself, and then restart the container. So you don't even have to actually open like the system or do any complicated steps. Rather, you just use the terminal of the application directly and replace your model. so that even if you want to show a new application apart from the ones which we already have, you can do it from A to Z inside using this web page dashboard.
Okay. Yeah, anybody who's done like presentations such as this webinar or at their job knows that you end up spending almost as much time on the visuals and the graphs as you do on the actual work sometimes. And so it's really cool that you can get these like really high quality, real-time graphs and stuff for basically for free without having to, create them by hand. It's pretty sweet.
Yep.
So quickly going back to the presentation. So yeah, so we've seen this application running on the system locally as well as on using the DevCloud web page. So how the application was built was there is just a minor uh, addition on top of the already existing EVM microservice. So it is that just uses very minor post processing script, the analytics results overlay, and it just adds the violation check, and the web browser is used just to view the results. So very minor, low code, I would say, because this is again a small part of code. It's just a function which will help you do a post processing, and then a very minor configuration, and that helps you create any video analytics application which you want to try out. And the dev cloud helps you understand how that application will run on any of the available Intel hardware. Yes, so for the closing comments, so basically with Edge Software Hub, what you can do is you can actually learn all of the available microservices, how they are connected to each other, and how an application is developed from end to end. Any machine learning or deep learning application, how it is developed using all of the available open source libraries, and especially OpenCV, OpenVino, and additional database and visualization libraries. And you can basically uh, directly understand how to develop a single application without having to really understand the complete software or the libraries aspect of it. And once you develop, you can just easily select any of the available reference solutions, and you can modify them slightly to achieve the end result that you're hoping for. And you can also run that on the available dev cloud platform without having to download it. And after you have developed the application and benchmarked it, you can actually deploy it back to the Edge Software Hub as an RFP ready kit or a market ready solution to help the scale the application and help showcase as a complete end-to-end new application on a software hub. So these are all the offerings that each developer would be entitled with once they start using the Edge Software Hub. And this basically removes all of the uh, heavy lifting from the Edge software development, and you just have really like good time and developing the application without having to resolve major of the bugs that one goes through when they try to develop everything from scratch.
Right. And this, all these services, everything here that you mentioned, except for the hardware, of course, is free, right?
Yes,
And
it's open
like
source.
we know from last several webinars that the dev cloud itself is also free, so you can test as much as you want on the dev cloud, use the hardware for testing. But all the software shown here, all the various services, everything is free, right? Intel makes its money
Yes.
by selling the hardware and not
Yep.
not this software stack.
Yes, everything is open source.
Okay, that's great.
Yeah, it's awesome. Are we done with the presentation for today? or is there more
Yes.
slides? All right. Yeah, thanks so much. This was really informative. I did not realize how powerful this the Edge Software Hub was. There's a lot to it, and the fact that it's free to use is incredible. So before we hit 10 o'clock, let's do our giveaway here. We'll go ahead and stop the screen share. Folks, if you're joining us for the first time, or if you just need a little reminder, every single week we do a giveaway to you in the audience. You have to be in the Zoom chat to answer and win. However, if you want to get into Zoom, you can go to opencv.live and join right now. You've got a few seconds while I ask the question. The first person to answer this question correctly will win the OpenCV course of their choosing. You can go to opencv.org/courses to see the course catalog as it stands today. If you have answered and won recently in the last, say, 2 months, please don't answer and give someone else a chance to win. Get ready to answer in the Zoom chat. First person to do it gets the course. Earlier in the webinar, we looked at a demo about social distancing. What is the correct distance that would not trigger a violation?
No,
Johnny
okay,
Lee.
Johnny Lee.
I see Johnny Lee. Partha, it's not meters, it's feet. We got tripped up. Congratulations, Johnny Lee, who answered correctly. The answer is 6 feet. 6 feet. Please send one email to phil@opencv.org with the course that you would like, and we'll make sure that you get that added to your courses account.
Yeah, Partha is he types very fast or something. He's closer to her. He always gets his answer first.
I'm expecting to go to the bathroom and Partha will be sitting in the shower like on a laptop, like just really optimizing the milliseconds there.
Partha is using audio analytics.
Yeah, must be. Congratulations, Johnny. You'll get them next time, Partha, I'm sure. We've got a bunch of questions here. Thanks so much, Smitha, for answering live during the webinar here. Really appreciate it. I'm going to read a few of them. We covered one already, which somebody asked if all these the things on the Edge Software Hub are free. They are available to use for free. It's also true of our presentation last week, or two weeks ago, rather. Let's see here. Someone asked if this ecosystem is HIPAA compliant. That's a very interesting question. I'm not sure there's enough context to answer that per se, but does anybody want to take a stab at that?
I want to know, is there any specific example they're referring to? Because HIPAA compliance is usually on a data that is on the patient and health data.
Yeah.
So I would assume, and I don't know for sure, I would assume that most of, when you're going to deploy this thing, then it's, let's say on the cloud or something, right? Then where you're storing your data is where the HIPAA compliance comes into play. But I don't know enough, what are the...
So adding to what Satya just said, there is an application called brain tumor segmentation, which is available on the Edge Software Hub. So basically, the images that we have used to train the models and deploy the solution are from the BRADS dataset, which is also an open source dataset. And in that, there were a lot of brain scans. And out of that, all of this skull information was removed manually by the BRADS dataset team. So I would say that is compliant because there is no patient information in that. So we make sure that whatever data we use for model training, as well as if there is some data which is already shipped with the application, every one of them has no legal implications whatsoever. But for data points which you use on your own, you have to take care of that so that it does not violate any conduct.
Yeah, so there are two parts to it. First of all, the data that is used for training, but also the data that how you're storing and keeping your data from the customer, right? When this is in production, how you're storing, etc. That also needs to be HIPAA compliant. And frankly, we should not. I mean, I don't think we know enough to comment on that, and it's a very sensitive issue. So I would recommend that, go and read the documentation and also, talk to, frankly, a lawyer. I mean, there's no other way to make sure that these things are all compliant. Yeah, so I would like to dodge this question because it is
You're-
sensitive. We should be respectful.
Yeah,
the
you got to
things that we don't know, we should not
You're
pretend.
responsible for your own data.
Right, right.
You didn't. Do I have to read the disclaimer again? I don't know if my voice can handle it. We got another question here. Someone would like to know, what's the tracking algorithm used in the example we saw?
So the example that we saw doesn't involve tracking the people. Rather, it is a frame by frame processing of the data. So at
Okay.
any given point of time in the frame, if there are two persons which is detected and they are less than 6 feet distance to each other, we would be detecting that as a violation count. So that is having a flaw. That consecutive frame will also have the same violation count by the
Mhm.
same set of people, but it would be frame specific.
Got it. That makes sense. And so, a different way to do that could be adding some kind of frame by frame knowledge so it remembers what happened or knows what's coming up next. And so
Yes.
you could count that as a single violation, but it would just be a different method to do it, a little more
And there are different
involved.
kinds of tracking also, right? One method of tracking actually works only on bounding boxes. It doesn't need the underlying image data, right? If you want to, I mean, it's not as accurate as the ones that use image data and do the tracking, but there are also algorithms that work only on bounding boxes. So you have a collection of bounding boxes in one frame, and you have collection of bounding boxes in the second frame. It figures out the association using, proximity, motion, and all kinds of things. So those things you can also do on top of the output that you're receiving.
Yeah, we got a question here from Richard. Are there any containers on there that take advantage of the Oak D camera or the Oak camera series?
This is the OpenCV AI kit.
Yes.
So at least as per my information, we do not have that yet. But if it contains any additional configurations, then our team definitely would work on that. So right now, what we have is we can process any of the locally stored video or any of the video coming from a live stream. So those are the two, or a web camera connected to the local system. So these three are definitely supported by the microservice that we just saw. But for any other specific video service which has an underlying set of additional configurations, right now it is not. It might not be available, but we need to check. Like, at least for my information, at least what I know, it's not available yet.
What about the Myriad series of processors? Does the Edge Software Hub have any specific optimizations or models for those?
Yes, Smitha, do you want to take that one?
I'm not aware of that, Phil. Sorry.
Okay. Yeah,
No, but it does say, I mean, in the presentation, I did see that you mentioned that Movidius, some of the devices on the in the dev cloud, they are Movidius devices, right? So a MyriadX basically is in that family.
Yeah, dev cloud, we definitely saw that.
MyriadX, right? So I'm guessing that it's probably there, right?
And when following on to that, when will we see support for Intel Getty on here?
So I've just finished trying out the Getty platform, and very soon we'll be trying to integrate that, because we are still trying to smoothen it out and help any developer understand the Getty first, and then once that is done and we have a stable, I think, integration platform design, it would soon come.
Cool, right on. It's a really exciting product. I'm looking forward to when we can get our hands on some as well at OpenCV. Put in a good word for us over there.
There is no need to actually put a good word, because it's already established that that is the best already.
Yeah, let's see. Speaking of processing AI stuff, there's a new blog post on the OpenCV blog, opencv.org, about using neural processing units, specifically the Kata Vim3. Go check that out. Anybody watching here, Satya, you want to take us home?
Yeah, a couple of more things I wanted to announce before. OpenCV face recognition, we have been rolling out the beta, right? So some people have tried it. And if you want to try out, go to our opencv.org and you'll find a link to the face recognition. Just register and you'll get access, in the next round when we roll out, we send it out to the next group of people. I also have a webinar, which is, on December 6th, titled, how to get started in an AI career, how to land an 100K AI job if you're a beginner. And even if you want to switch careers, right? And this time we have kept the time to be 5 p.m. Pacific time on December 6th. And this will ensure that people who were unable to join last time, which was in the morning, 9 a.m., they should be able to find this time more convenient, hopefully. So please join. And again, to get a link to the registration page, you can go to opencv.org and it should be right there in the front page. So yeah, that's all I wanted to announce. And thank you so much, Abhijeet and Smitha. It is a real pleasure to have you here. And frankly, I learned a lot. I did not know about these offering, and I'm going to check it out. It is really, really useful for people, even consultants like us who build solutions for companies. It saves a lot of work for us, to build the final solution. And thank you so much for, presenting. I really enjoyed the presentation. It was very clear, and all the steps are very clear on how to do it. And as always, I want to thank Phil for organizing this webinar. Thank you, Phil.
Oh, shucks.
And last but not the least, I want to thank all our audience members who show up every week. It means a lot to us.
Yes, indeed.
And it keeps us very, very motivated to keep this series going. Thank you.
Yes, thanks so much, everybody. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be. We'll see you next week. Same bat time, same bat channel.
Thanks so much for watching this episode of the webinar.
Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.